Alright, let's continue our discussion of more on functions. I've got a brand new thing for you, piecewise functions. And this entire video is about evaluating piecewise functions, graphing piecewise functions, and our very last problem will actually create a piecewise function from looking at a graph. And so a piecewise function definition is a function in pieces. Honest to goodness, it's a function defined in pieces. And so I've got one here for you below, f of x equals x plus 3, but that's only true for x less than negative 1. And then 2x plus 1 is only true for x greater than or equal to negative 1. So this part of the problem is like directions. So only for x less than negative 1. Okay, so you're not allowed to plug in numbers bigger than negative 1, only less than negative 1. And then these are directions again. This, you use the second one, 2x plus 1, only when, or for, x is greater than or equal to negative 1. So I'm not allowed to plug in like negative 2 into this one. I'm only allowed to plug in negative 1, 0, 1, 2, 3. So you will never plug the same number into both pieces. And by the way, it's possible to have more than 2 pieces either. You could have 3, 4, 5, as many pieces as required. In this book, we tend to stick to 2 or 3 pieces, okay? But really, there is no limit on the amount of pieces that you could have to represent whatever you're trying to represent in the real world. All right, now, here we're not going to graph. In this particular problem, we're just supposed to evaluate, okay? So remember what this means is x is equal to 4. So the next question is, which piece do I use? Okay, well it says use the first piece, the top piece, x plus 3, if x is less than negative 1. Well, it's not, right? 4 fits into the second piece. 4 is bigger than or equal to negative 1. So all I do is plug 4 into the second piece. Okay, so again, which piece is the second piece? And I do 2 times 4 plus 1, which is going to be, of course, 8 plus 1, which is 9. So f of 4 is 9. So that's exactly how you do it. So again, you analyze which piece. This means x is equal to negative 4. So again, which piece? Is it the top piece or the bottom piece? Well, negative 4 is less than negative 1. That fits in the top piece, okay, or the first piece. So you would just plug the negative 4 into the first piece. So it would be negative 4 plus 3 equals negative 1. Okay, and then finally the last one, negative 1. That's a little bit tricky, right? Because negative 1 is included in both directions. But the top piece says strictly x is less than negative 1. Doesn't include negative 1. But the bottom piece, 2x plus 1, says it's okay if x is equal to negative 1, because that's x is greater than or equal to negative 1. So again, this is the second piece, and I'm going to have 2 times negative 1 plus 1. So I'm just taking, again, the negative 1 and plugging it in right into that x value right there. This is going to give me negative 2 plus 1, which is going to give me negative 1. So that's how you evaluate a piecewise function. Next, we want to graph a piecewise function. So here's our first piecewise function to graph. Notice it's in 2 pieces. Again, the top piece, x plus 3, we only graph x less than negative 1. Okay, so I'm going to do a t-table for that piece all by itself. So I have x, and I have x plus 3, and the directions say I'm only supposed to plug in x's less than negative 1. So let's pick out numbers less than negative 1. So like maybe negative 4, negative 3, negative 2. Now what's the number right below negative 1? Now your answer is probably going to be negative 2, right? That's the integer right below negative 1. But really, the number right below negative 1 can't even be listed because there's an infinite amount of numbers between negative 1 and negative 2. So here's what I want you to do. I do want you to plug in negative 1, even though it says we're not supposed to. And remember that it's going to be an open circle on your graph. Okay, so it's the way I'll do these every time. You'll see it done again in a minute. And let's go ahead and calculate this piece. And so when I plug in negative 4, it'd be negative 4 plus 3, which is negative 1. When I plug in negative 3, it'd be negative 3 plus 3, which is 0. Plug in negative 2, it'd be negative 2 plus 3, which is 1. And then the one I'm not supposed to plug in, but I got to know where the open circle belongs, negative 1 plus 3 is 2. So I want to plot these points on my xy axis. So negative 4, negative 1, negative 3, 0, negative 2, 1, and then the weird one, negative 1, 2, but I'm going to put an open circle there. Okay? Now, I connect the dots. Normally you connect them left to right, just as we would here, just like that. Are you surprised that's a straight line? Remember the rules for straight lines is x is to the first power and y is to the first power. Now, y is always to the first power if it's in function form. Okay? So we knew this was a straight line, so really 4 points is not required. But what is required is this point right here, because you've got to know where the hole goes, and some other point. And I suggest plugging in extras anyway. Now, normally a straight line has an arrow on both ends. This cannot have an arrow on the right side because there's that open circle. It does not continue on. But over here on the left side, it does continue forever. So it is appropriate to put the arrow on one end. For a piecewise function, you will not have an arrow on each end of your piece. Alright, now let's graph the second piece. Okay, so I'm going to do a t-table. I'm going to have an x, and then my second piece is 2x plus 1, which is my y value. Now, it says I'm only supposed to plug in x's greater than or equal to negative 1. So I actually can plug in negative 1, and then I can plug in, say, 0, 1, 2. That should be plenty. Okay, now, at negative 1, because there's an equal to, when I plot that point, it's going to be a filled in circle. As opposed to the first one, we had an open circle, it's going to be filled in. And I'm going to take each of these and plug them in. So it's 2 times negative 1 plus 1. 2 times negative 1 is negative 2 plus 1 is negative 1. Then 2 times 0 plus 1. I don't know what's wrong with my computer that it's bouncing around like that. I apologize. 2 times 1 plus 1. Which is 3, and then 2 times 2 plus 1, which is 5. Okay, I'm going to plot these points. So I've got negative 1, with a filled in circle. So that's here. Okay, 0, 1, right here, 1, 3, here, and 2, 5. Right there. Now, are you surprised that's a straight line? I hope not, because we have talked again, x to the first power is always a straight line, and then there is our line. Now, remember the arrow cannot go on both ends. It can only go on possibly one end, but this says x bigger than or equal to negative 1, so I'm allowed to plug in larger and larger numbers, which means the arrow goes on this side, and the filled-in circle goes on this side. Now, here's what I want you to check. Does this pass the vertical line test? What do you think? If I draw vertical lines on this, now your first hang-up might be, uh-oh, right here, what about it? X equals negative 1. Well, remember, this is an open circle. It's a filled-in circle, so this does pass the vertical line test. And I like students to, whenever they graph a piecewise function, to check to see if it passes the vertical line test. Because that's a good way to check to see if you drew one line too long or accidentally put an arrow where it doesn't belong. So please check that out for me. Now, next, let's graph another piecewise function. The more you practice these, the better you'll feel about it. For our next piecewise function, we have negative x. Our first piece is negative x as long as x is less than 0. Okay, so let's draw a t-table for that. So we have a column for x, a column for y equals negative x, or you can just put negative x there to remind yourself. Now, I'm only supposed to plug in numbers less than 0. So let's list numbers less than 0. I don't know, negative 3, negative 2, negative 1. Now, do I include 0? Well, on your t-table, you better. But remind yourself there's an open circle there. So if it doesn't have an equal to, you do include that number always, but with an open circle. Okay? Now, this feels weird to plug in negative 3 into negative x. Okay, so the negative in the function is just part of the function, and then you plug in -3 for x. So negative of a -3 is 3. Basically, all that negative done is change the sign. So negative of a -2 is, of course, 2. Negative of a -1 is 1. And negative of 0 is still just 0. So let's plot these points, okay? So -3, 3. So -3, and then I'm up here at 3. And then -2, 2. -1, 1. And then my open circle is right on top of the origin, 0, 0. Alright, now that's a straight line. Are you surprised? Please don't be, because it's x to the first power, and f of x is always y to the first power. So I connect the dots. Now the question is, where does the arrow go? Well, it certainly doesn't go where the open circle is. It goes on the other side. Okay? Now let's graph our second piece. Alright, so t-table. I'm going to plug in x's using my directions, and my answer is y equals, well, that's weird. There's no x, it's just y equals 5. Is that bad? Nope, not at all. So first of all, let's go by our directions. Our directions say plug in 0 and bigger. Alright, so I'm going to plug in 0, reminding myself that it's going to be a filled-in circle because the 0 is included. Then I'm going to plug in, say, 1, 2, 3. That ought to be enough. So all these numbers are 0 and larger. Now, where am I plugging this into? Well, there's no x. But that's okay, because the function tells us no matter what, y is 5. Okay? So for 0 we get 5, for 1 we get 5, for 2 we get 5, and for 3 we get 5. Let's plot those points. So 0, 5, again, my filled-in point. 1, 5, 2, 5, 3, 5. Now this graph normally is constant function, horizontal line. We would go far to the left, far to the right, but this thing doesn't go to the left. 0 is the smallest number we can plug in, but it does go forever to the right. Okay, now do your quick vertical line test in your mind. Does it pass? Sure it does. The only issue could come down right along the y-axis, but this is open, so it doesn't mean it's actually defined there. The point is defined there, so we are good. Alright, the last piecewise function that I have to do in the video. Alright, we have an x value, and then y equals the first piece, which is x squared plus 1. Notice it says x is less than or equal to 2. So I need to plug in numbers less than and also equal to 2. So how about, I don't know, -2, -1, 0, 1, 2. My question to you, is this a straight line? Nope, because it's got a square in it, right? Also, at 2, is it filled in or is it open? And it is filled in. So I'm going to go back to -2 and do -2 squared plus 1. When you crunch those numbers, you get 5, right? Because -2 squared is 4. 4 plus 1 more is 5. Then -1 squared plus 1. -1 squared is 1, plus 1 more is 2. 0 squared plus 1. 0 squared is 0, plus 1 more is 1. 1 squared plus 1. That's 1 plus 1 is, oops, 2. I'll copy that. And then 2 squared plus 1. In our filled-in hole, again, each one of these goes on both t-tables. One of them is going to be filled in, one of them is going to be open, and the filled-in one is the one with the equal sign. So 2 squared is 4 plus 1 is 5. So let's plot these points. -2, 5. Okay, get a thicker point. -2, 5. There we go. -1, 2. 0, 1. Remember, this is not a straight line, so don't get nervous when it flips back the other way, just like it did right there. And finally, 2, 5 is filled in. This is a parabola. We already know that x squareds give us parabolas. There it is. But now which one keeps going? Okay. Well, I can't graph this thing for anything bigger than 2. So to the right, it stops. But to the left, this keeps going up and up and up. Not as squirmy as I just made it. Again, my slippery computer face makes me do terrible graphs. I apologize. Alright, but that's that piece. That is x squared plus 1 for x's less than 2 only, including 2. That's why that's filled in. Now let's do our second piece of our t-table. Let's do purple. Alright, here we go. Okay, so I have a column for x, and I have a column for y equals x minus 2, or just x minus 2, whatever you feel better about. I'm only supposed to plug in numbers bigger than 2. But remember my requirement, you have to plug in 2, but you have to establish, is it filled in or is it open? Well, there's no equal to next to that 2, so it is open. And then I plug in numbers bigger like 3 and 4 and 5. And now I'm plugging it into x minus 2, which is a straight line, right? Because it's x to the first power. So I'm doing 2 minus 2, which gives me 0. 3 minus 2 gives me 1. 4 minus 2 gives me 2. And 5 minus 2 gives me 3. I'm going to plot these points. Okay, so 2, 0, I have an open circle. All right, 3, 1, filled in. 4, 2, filled in. 5, 3, filled in. I connect the dots on my straight line. Again, we know it's straight because of the exponents. Usually a straight line has arrows on both ends, but I'm not allowed to go past this open circle. I'm only graphing for x is bigger than 2, so that means everything after 2, 0 and to the right forever. Now, does that pass the vertical line test? Sure does, right? Our issue comes right in here at x equals 2, but it's open right here on the x-axis at 2, but it's filled in up here at 2, 5. So this is perfectly okay. Okay, got one more problem for you to think about. And you may recognize this problem. This is on the opening page. If you've watched all 3 videos for this section, you're like, yep, I recognize that guy right there. Well, here's what I want you to do. I want you to write a piecewise function for this graph. Okay, it looks a little like the last one we did, right, with that parabola. Okay, now the good news is I give you the equations. Okay, so let's just call this something. You can call it f of x or g of x or whatever your favorite letter is for a function. I'm just going to call it f of x. Now, my piece to the right, okay, so notice this is a parabola. It's y equals x squared, so all I write down is the x squared. Okay, and it looks like the x values graphed are all the way from, let me get a highlighter here, negative infinity all the way to whatever that value is right there, and I'm going to assume that it's 2. This graph did not give me a scale, so I'm just going to assume this is a regular scale, and by the look of the graph it is a regular scale. So from negative infinity to 2, then that's what I've got going on here. So how do I write that down in just regular old inequality notation? Well, negative infinity to 2 means x is less than 2, right? That's what negative infinity to 2 means. Do I include the 2? Well, no, because there's an open circle right there. Okay? Now, my next piece, and this is weird, is just 6. You can't forget about that. So I have a piece that is just 6, just the number 6. Now, when do we use that piece? Well, only when x is equal to 2. No other time is 6 defined. It's just the point 26. So the answer is 6 as long as x is equal to 2. Okay? Now this is not one of those situations where you have a less than and then a less than or equal to, because this is open and then this one up here is open as well. Both of these are open. So to fill in that piece in the middle, I have to have a separate line that just says 6. And then my third and last equation is 10 minus x. So it says y equals 10 minus x. Okay. Now, where does that start and where does it end? It actually has a beginning and an ending point. The x value this begins at is 2. So let's say 2 is less than x. You say x is bigger than 2, but we're going to write this as a compound inequality because it also stops at, and what is that x value right there? 1, 2, 3, 4, 5, 6. It stops at 6, but now that's filled in, so that's less than or equal to. So take a minute. I know that might be faster than you want. Take a minute and go back and watch that. I'm not going to give you a bunch of these. The homework doesn't give you any of these. I don't recall anyway, but I think that's a neat problem. And since I kept opening up the videos with this graph, I wanted to address it. So we wrote a piecewise function for this particular graph. I hope this helps you with this entire section. We have covered thoroughly functions. We're going to continue in the course by talking about specific types of functions. So these two sections were a large overview of functions, and you got 6 videos you can watch about a large overview of functions, and then we're going to get more detailed with specific types of functions following.